Let's take a look at some of the basics of graphing our new kind of function, the rational function, something that has an x in the bottom of the fraction in the denominator. This kind of graph is something called a hyperbola. And so let's begin with domain and range. We've kind of been talking about that a lot this semester. The domain is always what we are or are not allowed to plug in for x. And in this case, since x is in the bottom of a fraction, there is only one number that we never, ever, ever want to divide by, and that number is 0. And so for our parent function, before we start shifting things around in the next video, our domain is simply going to be all the real numbers except for 0. That's the only number we don't want to plug in for x. Similarly, our range is going to be y, our output, cannot be equal to 0. There's nothing we can plug in for x that's going to get us 0 as an answer when we divide. So there's our domain and range, once again, until we start shifting things around. There are two asymptotes that we'll have for these rational functions, these hyperbolas, a vertical and a horizontal one. And our domain is going to be linked to our vertical asymptote. So if our domain is x cannot be 0, that means we're going to have an asymptote at x equals 0. So let's go ahead and go to our graph. This axis right here, the y-axis, is going to be our vertical asymptote. The equation is x equals 0. I will not have a graph at that location. There'll be a break in my graph. And the reason that is because I cannot divide by 0. If I plugged in a number or 0 for x, I would not have an answer. There will be no graph there. Similarly, our range is connected to the horizontal asymptote, and our range for this function is going to be y is equal to 0. So there's our horizontal asymptote. So let's draw that in as well. In other words, it's the two axes in this case. However, those will start changing, like I said, in the next video. And turns out, to me at least, what's more important on these graphs is not the graph itself, it's the two asymptotes. And so for the graph, the hyperbola, I'm not going to plot any points. I'm just going to sketch what this looks like. A hyperbola is made up of two pieces that we call branches. And so for our parent function, we're going to be here in the first quadrant. So go ahead and just sketch a graph that looks something like this. It's going to approach both axes, both asymptotes, but never quite touch them, and there'll be arrows on both ends. That's one of the branches in that first quadrant. I guess let's go ahead and label our quadrants. There's quadrant 1, 2, and then quadrant 3, and quadrant 4 is down here. So with this parent function, we have part of our branch, or one of our branches in quadrant 1, and the other branch in quadrant 3. So there's a graph of what this basic parent function is going to look like. Again, I didn't plot any points. If you want to plot points, you can take a look at your calculator, which we'll do in the next video. However, for me, I don't need points. I want the asymptotes to be drawn in the right spot. The graph itself can just be a sketch. Okay, let's go ahead and start to talk about this next example. Oops, there we go. I was having trouble with getting my example to pop up, but there it is. Let's start to talk about this, but then we'll go ahead and switch to a calculator to actually see what's going on. The first thing that I want to note when I'm graphing y equals 6 over x is that my domain range, vertical and horizontal asymptotes have not changed. They're only going to change if we add something. And so the number I still do not want to divide by is 0. I still do not want to have a 0 in the bottom of the fraction. My range is still y cannot equal 0. And then once again, because these are linked, the domain and the vertical asymptote are linked, that vertical asymptote is going to be at 0, and the horizontal asymptote is linked to the range, and that's going to be at y equals 0. So once again, I'm going to have the branches approaching the two axes. What I want to see then using my calculator is what happens when that a value becomes bigger. When that a value is a 6, what happens to the graph? And then also this question down here, what's going to happen if we have a negative 6 instead of a positive 6? And so you may want to make a couple of predictions, but let's go ahead and switch over to the calculator and actually see what happens to the graph. So we've just established that for the function y equals 6 over x, our domain range, vertical and horizontal asymptotes have not changed from the parent function. All we've changed was that number on top, which we'll call the a value. Let's take a look at the two graphs and see what happens. So I've already entered in 1 over x and 6 over x. If you need to do this at home, go ahead and pause the video and do that. But let's take a look, if you're ready, about what that value does. So here in blue is the original one, 1 divided by x. Notice the asymptotes, or the axes. And here in red is my second function. Notice that all that 6 did was kind of push the graph away from the center a little bit. Since I'm not having you plot any points, that doesn't really matter for what we're doing. However, if you need to plot more points, if your teacher's asking you to do that, or if you want to, you can go ahead and look at the table to plot some more points. There was one question that I also asked, and that was, what do you suppose would happen if the 6 was a negative 6 instead? And so while I get this typed in, maybe you want to make a guess. I'm going to delete the 1 over x. And you can see if you are right. So I'm going to leave the 6 over x so we remember what that one looked like. And I'm going to graph negative 6 over x as well. So let's see what happens. Hopefully you've made your prediction by this point. Let's see if you're right. So here actually is the negative one. That's graphing first. And then here was the positive one in red. So notice what happened. If we have a negative a value, all that's doing is it's flipping the quadrants that your graph is located in. So rather than be located in the first and third quadrants with a positive value, a negative a value puts you in the second and fourth quadrants. Was your prediction right? Hopefully.